So I thought I'd walk through this problem here, 18.3, problem 19, part A, because I think it is a bit tricky here. What we're trying to do, integrate across path C1, like that, of, f dot dr. And in order to do that, really you need to break that path up into two pieces, the vertical piece and the horizontal piece, right? And you can really think of that vertical piece then. So for this vertical piece, we know that the x values are all 0, okay? So in integrating that part, I mean, you can think of it, we're going from essentially 0, 0 coordinates to 0b, and this vector then, essentially, I mean, it's just the y coordinate, y comma y, because the x's were 0, dot dr. Oops. There we go. And then add to that the second piece, which is the horizontal component going across. So that you can think of as the integral from the point, 0b up to ab. And in that case, the y value is a constant b, so our vector field going across this is x plus b, comma, 2x plus b dot dr. And now it's a matter of talking about, well, what are the paths themselves? We now need to parameterize the paths then. So for this vertical parameterization, you can say, look, this path, the r path, the position vector, in that case, we could just parameterize it by 0t as t goes from 0 to b. And so that makes this first integral then an integral from 0 to b. The y values are just t now, t comma t. And then the dr would be the derivative of this, which is 0, 1, right? And then dt. Then the second part here, a horizontal path, in that case we can consider the path vector, position vector, to be t comma b, because the y is constant in that case. And then in this case we get the same idea of f dot dr. So now we're integrating the t values here are the x values going from 0 to a, and this becomes a t plus b, comma, 2t plus b. T is just replacing the x's. The dr in this case, look at the derivative, it's going to be 1 comma 0 because the b is constant, dt. And so we can do these dot products. So this dot product just ends up being t dt, and this dot product ends up being t plus b dt. Oops. So at this point it's pretty straightforward, right? We have a 1/2 t squared, and that's going from 0 to b, and then this portion becomes a 1/2 t squared plus bt, and that gets evaluated from 0 to a, and we get a 1/2 b squared plus 1/2 a squared plus b times a. Now you probably could have done this top part maybe a little bit quicker here, recognizing that in a vertical component, yeah, you're only going to get a y component out of this, and likewise in the horizontal component you're only going to have the x component. So you probably could have jumped through this step a little bit quicker, okay, to get to the same result. And then parts B and C then really work the same way. So hopefully that helps.